Welcome to another exciting educational video brought to you by ChrysoliteTutors. So we're here with master calculation, excel in science, and learn anytime. We're looking at past questions in JAMB Physics, and we'll be extracting questions from electricity and magnetism. So we'll dive straight to the question number one. We have the fundamental property of matter that gives rise to electric forces is called A. Mass, B. Charge, C. Density, and D. Volume. So the answer is uh, charge. Electric force exists because particles possess charges. There are two kinds of charge. You have the positive or the negative charge. These charge interact through electrostatic force, like you see like poles attract and unlike poles repel. So examples of charges include protons. Protons carry positive charge and the electrons carry negative charge. Without charge, electric forces cannot exist. So the correct answer for this question is B. The fundamental property of matter that gives rise to electric force is called charge. So number two question says the point 2 point charge plus 3 microcoulomb and plus 4 microcoulomb repel each other with a force of 10 Newton. If each charge receives an additional charge of minus 6 uh, microcoulomb, what will be the new force between them? So we have these options. Which one is the answer? We're going to be writing the Coulomb law. The Coulomb law says that the force of attraction F is directly proportional to the produce of the charges and inversely proportional to the uh, the square of the distance separating the two charges. So F in this equation is force, K in this equation is a constant known as 9 times 10 raised to the power 10, and the Q1, Q2 are charges, and R is the separation distance. So we put in the parameters. I know that we have Q1 as 3 microcoulomb, according to the question here, and Q2 has 4 microcoulomb, according to the question here. But there's an additional charge, which is minus 6 microcoulomb. So where would that be? Now, we need to resolve the forces or the charges. So the first one, the new charges, you have a Q 1 prime. So it is going to be 3 minus 6. 3 minus 6 will give us minus 3 coulomb. And the Q2 prime will be 4 minus 6 will give us minus 2 coulomb. So I have Q1 prime, Q2 prime as new charges. So compare with original force. Original force, we're going to put in the force formula. F is equals to K, then Q1, Q2 over R square. And at this point, Q1 with original force, we're having that Q1 is 3 microcoulomb and Q2 is 4 microcoulomb. So we'll put it here. So original force and the new force, we're going to get the different force. So original force is F and new force is F prime. So we multiply and we'll get the original force and the the new force. So original force is given as 3 times 4, which will give us 12. So the force becomes F prime 6 over 12 times 10. F prime will now be 5 Newton. Okay, so if you check now, the answer is D. So the next question is talking about uh, electric field. The question goes like this. So the region around a charged object where its electric field force can be felt is known as. Now what is the correct answer is actually electric field. So that is the region where electric force can be felt. But explanation: an electric field is actually the space around a charged body where another charge experiences a force. So the formula is actually force per unit charge, where F here is force and Q here is the charge. So this is the electric field. So the unit of electric field is Newton per Coulomb because force is in Newton and charge is in Coulomb. Okay, so the next question is on electroscope. An electroscope is used to measure A, current, B, voltage, C, detect the presence and type of charge, and D, generate electricity. So the answer is C, detect the presence and type of charge. So how is that? An electroscope is a device used to one, detect the presence of electric charge, and two, to determine the nature of the charge, whether it is positive or negative. Okay. So common type of electroscope. You have the gold leaf electroscope. And how does it work? When a charge enters the metal cap, the charge spreads to the leaves. The leaves acquire the same charge. The leaves repel and diverge. So like charges repel. That is why the uh, there is a diversion or repulsion. Okay, number five is all about Ohm's law and current electricity. It goes like this. A cell of EMF 1.5 volts and internal resistance 0.5 ohm is connected to an external resistor of 2.5 ohm. Calculate the current flowing in the circuit. Calculate the current flowing in the circuit. So the first thing we have to do is to find the total resistance. Now we have two kinds of resistance here. One is internal resistance. This one is small r, and the external resistance, this one is big R, right? So total resistance is big R plus small r. That is external resistance plus internal resistance. Okay, so then we can get the total resistance by just the addition of the two kinds of resistance. So internal resistance, total resistance is giving us 3 ohms. Now the next thing we do is to go and apply Ohm's law, where we have I is equals to E over R, where I is current, E is EMF, that's electromotive force or voltage, and R is the resistance. So just plug in this. We've already gotten the resistance as 3 ohms. So 3 ohms will come in here, and what else? 1.5 volts will come in here. So I'm going to be plugging it in. 1.5 divided by 3 will give us 0.5 amp. 0.5 ampere is option B. Option B. Okay. So number 6 is saying the capacitance and dielectric. So the capacitance of a capacitor is 20 microfarad in air and 60 microfarad. When the dielectric is inserted, the dielectric finding the electric constant. Okay, so there's a formula for that. So for the formula, we have K is equals to C dielectric over C air. That is capacitance in the dielectric and capacitance in air. That will give you the dielectric constant K, right? Okay, so yes, so where K is the dielectric constant, yes, and C is the capacitance with dielectric, and CD, CD is the capacitance with dielectric, and CA is capacitance in air. So they are well defined. So we substitute the values. I have K is equals to 60. This is the 60. 60 is what? The dielectric in the capacitance with the dielectric, that's 60 over the dielectric in air, that's 20. Right? So that will give us 3. So the meaning is that the dielectric materials increases the capacitance 3 times. That is the interpretation. Okay, the next one is looking at capacitors in parallel. Question here says 3 capacitors, each of 2 microfarad are connected in parallel. So this is parallel connection. That's how it looks like. Capacitance 1, maybe C1, then parallel capacitance C2, and capacitance C3. So these are how they are connected in parallel. Okay. So we're asked to find the total capacitance. Okay, so for parallel connection, total capacitance is the sum of each of the capacitance. So C1 plus C2 plus C3 will give us the final answer. And we are told that each of them are 2 microfarad. So it's 2 plus 2 plus 2, which will give us 6. So 6 is the answer here. Okay, so for JAMB, know that parallel capacitors increases capacitance, while series capacitors reduces capacitance. So because they are connected in parallel here, the capacitance will increase, and if they are connected in series, it's going to be for series the total capacitance is 1 over C T is equals to 1 over C1 plus 1 over C2 plus 1 over C3. That's for capacitance in series, right? Okay, so the next question is testing us on energy stored in capacitor, and it goes like this. 3 capacitors, 2 microfarad, 4 microfarad, and 8 microfarad are connected in parallel across a 6 volts battery. Find the energy stored. Okay, find the energy stored. Okay, so by diagram it's like this. They are connected in parallel. So C1, C2, then C3. They are all connected across uh, volts meter. So this one is 6 volts, and C1 is 2 microfarad, C2 is 4 microfarad, and C3 is 8 microfarad. So this is how they are connected. So we're asked to find the energy stored. The formula for it is okay. First off, we need to get the total capacitance, and then because they are all connected in parallel, the formula is 2 plus 4 plus 8 to give us 14 farad, 14 microfarad, or 14 times 10 to the power minus 6 farad. So, but then energy is given as half CV square. Okay, so this C is the total capacitance which we have gotten as 14 times 10 to the power minus 6, and the V is just 6. So plug in the values. So this is half times C, then times V square. So the answer is uh, 2.52 times 10 to the power minus 4 joules. So the option here is C. Okay, so Ohm's law, a resistor of 5 ohms is connected across a 10 volts battery. Find the current flowing. Okay, so this is very easy. Ohm's law states that voltage is equal to current times resistance, right? So we are arranging it. We have making I such the formula. We have I is equals to V over R. Okay, so we just plug in what we have there. 10 is given in the question as volts, and 5 is given as the resistance. So current will now be 2 amperes. Remember that Ohm's law states that the voltage is directly proportional to the temperature, the current, provided the temperature is kept constant. When you remove this proportionality constant, you will get in V is equals to R times I, where R is the resistance at that circuit. Okay, question 10 is testing us on resistivity. The question here says a wire has a length of 2 meters, cross-sectional area of 1 times 10 to the power minus 6 meters, and resistance is 4 ohms. Find the resistivity of the materials. Okay, so what is resistivity? Resistivity is resistance, this is resistance times resistivity, resistivity is equals to that's times length and over area. So I'm just defining what all these symbols mean. R is resistance, rho is resistivity, length is the length, L is the length of the material, and A is the cross-sectional area of that material. So substitute the values, we make a resistivity formula. Resistivity is standing alone here now, and I have R times A divided by L. So R here is given as 4. 4, this is 4. R is given as 4. Yes, from the question, see, resistance is 4. Then the cross-sectional area, A, is this, that's this, and the length is 2 meters. So notice how everything is in meters. Say meters here, it's meters here. By the time you compute, you're having resistivity as 2 times 10 to the power minus 6 micrometer, ohm meter, sorry. Right, so the next question is going to tell us about EMF. So it's a theory, a non-calculation question. It says that the electromotive force, EMF, of a cell is defined as the work done in moving a unit positive charge dash. So what is it exactly? So actually, the answer to this question is that EMF is the energy supplied by a cell per unit charge. Per unit charge. So the formula for EMF actually is the energy over the charge, right? Okay, so we're trying to arrive at the answer. So where EMF, E is EMF, W is work done, and Q is charge. So EMF actually refers to the work required to move a charge through the entire circuit, including external circuit, internal circuit, and the correct answer is around the complete circuit. So if we have tried to deduce the step by step how to arrive at this answer. So the EMF is just the work done, is the work required to move a charge through the entire circuit, around the complete circuit. So the answer is C, both internal and external, right? Okay, so 12 has to do with resistors in series. How is resistors in series? Resistors in series is when they are connected in a daisy chain, one after the other, right? This is symbol for resistance. So R1 is connected to R2 and R2 is connected to R3. So they are all in a straight line. Now, if we have three resistors, one is 2 ohms, this one is 2 ohms, this one is 3 ohms, and this one is 4 ohms in series. The effective resistance R T is equals to R1 plus R2 plus R3. This is how you get resistance in series. So I have 2 ohms plus 3 ohms plus 4 ohms. Okay, so 2 plus 3 is 5, 5 plus 4 is 9. So I have 9 ohms as the total resistance in series. Okay, so if they were in parallel, the answer would take another form. So important rule in JAMB is that you should know the series circuit. Current is the same. So if for series circuit, current is the same. Okay, let me do an analysis. If current is flowing through here like this, current I is flowing through here. The same will flow through here, flow through here, flow through here. But voltage divides. For series circuit, voltage divides. So the voltage that will be here will be V1 different from V2, different from V3. So the voltages will be different, but current will be the same. But vice versa, if you have it is in parallel, the current will split and the voltage will remain the same. Okay, I can quickly illustrate that again using a fresh space. Okay, so I want to illustrate this last point here. Again, it says that um, for series circuits, this series like this. Okay, please take note of this for jam purpose. R1, R2, R3. They are in series, right? So current remains the same. Current that will flow here will just flow. The same current will flow, the same current will flow, the same current will flow. But the voltage will be different. So I have voltage drop across R1 as V1, voltage drop across R2 as V2, voltage drop across R3 as V3. It will be different. It will be divided. But if it is in parallel, I have the circuit connected in parallel like this. Okay, so just Okay, so this is R1, R2, and R3. So voltage will be the same because the voltage drop is across all of them. This same voltage V is, but the current, when the current start flowing, when it gets to this place, it divides into three. So I have I1 here, I2 here, and I3 here. Okay, so that's okay. So the next question will test us on capacitors in series. Capacitors in series. So it says two capacitors, 3 microfarad and 6 microfarad are connected in series. So this is how the capacitors are in series connection. So C1 and C2, where C1 is 3 microfarad and C2 is 6 microfarad. They are connected in series. Find the combined capacitance. So combined capacitance, 1 over Ct is equals to 1 over C1 plus 1 over C2. So in series, capacitance are connected like this, and this is the formula for it. So we are to find the total capacitance. We are going to put in the values of C1. C1 is 3 microfarad and C2 is 6 microfarad. So at this point, we will need to calculate it by simplifying, getting the LCM, right? Get the LCM of 3 and 6, uh, do a sum, and make CT series of formula. So final answer, CT is equals to 2 microfarad. Okay, so for capacitors, series capacitance reduces and parallel capacitance increases. The next question tests us on thermal voltage. Thermal voltage. See, a cell has EMF 12 volts, internal resistance 2 ohms, and current is 2 amperes. Find the terminal voltage. So terminal voltage V is given as E minus IR. This IR, I small r, is known as the loss voltage, right? Loss voltage. Okay, so but then we're asked to find the terminal voltage, right? Now, from the question, we're given EMF as 12. So this is 12 minus internal current. The current is 2 and internal resistance is 2 again. So this is straightforward. By the time I put everything there and solve, I'll be getting 8. So key concept here, terminal voltage is always less than the EMF. This one is EMF bigger than this one, right? Uh, when current flows because some voltage is lost inside the cell. So I talked about loss voltage. That loss voltage is I small r. Okay, so then question 15 is about energy stored in a capacitor. So a capacitor of 10 microfarad stores a charge of 10 microcoulomb. Find the energy stored. So this one too, you need to know the formula for energy stored. There are different types. So this one now is Q square, okay, because we are giving it in form of uh, charge and Coulomb, okay. Yes, sorry, W is the formula of 1 over 2 CV square, and there's W is equals to Q square over 2C. Yes. Yes, so for this particular case, we are using this formula, because we have charge, and we have the capacitance. So by the time we plug in the values there, we're using this second formula because we have charge and capacitance. If we have capacitance and voltage, we can use the first one. So the final answer is work done is equals to 5 times 10 to the power minus 4 joule. The answer is A. Okay, number 16 is testing us on electric power. An electric heater is rated 100 watts, 220 volts. Calculate the current drawn by the heater. Current drawn by the heater. Okay, so power is equals to VI or IV, where P is power, V is voltage, I is current. So we are making I series of formula because we are told to calculate current, And we already have power here as 1000 watts and voltage here as 220. This is simple enough. Simple enough. So we just plug in the formulas and get the answer as 4.5 amperes P. Okay, so this number 17 is testing us on electrical energy. It says a 100-watt bulb is used for 5 hours. Calculate the energy consumed in kilowatts per hour. So energy formula E is equals to PT, where P is power, T is time, and convert power to kilowatts. 100 watts makes 0.1 kilowatts, 0.1 kilowatts, right? So substituting that formula, that's what I mean. So E is 0.1 times 5. So getting 0.5 kilowatts per hour. All right. Number 18 is on potential difference. A charge of 3 Coulomb passes through a conductor and a 15 joule of work is done. Find the potential difference. So potential difference V is equals to work over charge. Yes, work over charge. So V is potential difference, W is work done, and Q is charge. On substitute, we're having 15 over 3 and the voltage is 5. Answer is A. So number 19 is talking about resistivity of a wire. So it said a wire has resistance 10 ohms, length 2 meters, and area, cross-sectional area as 5 times 10 to the power minus 7 meters square. Find the resistivity. So the formula R is equals to resistivity times L over A. So we can make resistivity the formula. That's what we've done there. We plug in the values from parameter that we have. So if the first one R here R here is R here is 10, so that I'm having 10 here. Then A here is 5 times 7 minus 70 minus 7 is A, and L is 2 meters. So I have 2 meters here. So just do the math, and I'll be getting 2.5 times 7 minus 6 ohm meter. Finally, for this section, parallel resistors, two resistors, 6 ohms and 3 ohms are connected in parallel. Find the equivalent resistance. So parallel connection, 1 over RT, where RT is the equivalent resistance, is equal to 1 over R1 plus 1 over R2. So I'm looking for 1 over RT, right? And R1 is 6 ohms, so I say 1 over 6 ohms plus R2 is 3 ohms, 1 over 3 ohms. So I do my uh, LCM. 3 and 6 LCM for 3 and 6 is 6. 6 into 6 is 1. 1 times 1 is 1 plus 3 into 6 is 2. 2 times 1 is 2. So this is 1 over RT. My goal is to find RT, right? So this 1 over RT is equals to 2, 1 plus 2 is 3 over 6. So if I flip it both sides, RT now becomes 6 over 3, which is 3 here 1, 3 here 2, which is 2 ohms. So the required resistance is 2 ohms. That's the answer here. So I hope this video has been for you. I'd like to thank you for viewing.